prerequisites, design of machine elements, and fluid mechanics. I hope everyone has learned design of machine elements and fluid mechanics. Now
Yes,
here,
sir.
course outcomes. So prepare in and second course outcome is in piping system as requirement. And third, apply various national and international standards and codes. Based on that, can consider course outcomes. Now, course contents. So there are 6 topics or 6 modules in this subject. First one is the introduction. Second is the piping system layout and drawing. And third one is pipe supports. And next is walls and auxiliaries, mechanical piping design, and stress analysis. So here in the introduction, we'll see the scope of pipings, codes and standards, mechanical design fundamentals, mechanical design of piping systems, wall thickness, piping size selections, piping elements, and specialties. Next is pipe representations, welded and flange fittings. This is all about introduction. Now second topic is piping system layout on drawing. So in this topic, see the piping layout, equipment layout, process piping layout, pipe flow sheets, plan and isometric representation of piping systems and plot plan. Now in third topic, pipe supports. In pipe supports, low down structural supports, supporting structures on pipelines, pipe supports. So here in pipe supports, we'll see design considerations, platform and ladders. Next is foundations, supporting span of overhead pipelines. And stiffness, stiffing ribs and flexible hanger support. So that kind of support studied in pipe supports. Now, fourth topic, walls and auxiliaries. So here we see the different materials, wall materials and method of constructions, pressure drop in walls, wall size and types of walls, fittings, pressure relief devices, design of pressure relief system. The next topic, mechanical piping design. So in this topic, see the nominal pipe size that is called NPS. Pipe sizing by internal diameters, that is ID, and another pipe size we call the outside diameters. And here we can lay final pipe size, then piping drawings and piping stress design, internal or external fluid pressure stresses, expansion effect and compensation methods. So that kind of subtopics we'll discuss in mechanical piping designs. Now next topic, that is stress analysis. So in stress analysis, we'll see the types of times, thermal effects, flexibilities, and introduction to dynamic analysis software for stress analysis. So this is all about course content of piping engineering. Now see some textbooks and reference books for piping engineering. So here textbooks, DK Sahu Handbook of Piping Designs is published by New Age International Publisher, second edition 2009. And next is Sabine Crocker Piping Handbooks. It is published by McGraw-Hill, publication 5th edition 1968. And third, that is edition of Bouchercher and Roger Hunt, process plant layout and piping design. So it is published by Pearson Prentice Hall, 1993. These are the textbooks. And recommended reading some handbooks and books. So first handbook is Piping Handbook Mohinder L. Nair. It is published by McGraw-Hill, 7th edition, 1990. Next one is ASME by code engineering and 33 process piping. So here ASME stands for American Society of Mechanical Engineers. So from standards, study the piping codes B31 for piping for power piping and code 33 for process piping. Now third is pipe supports. The catalog PH82A NHK Spring Company Limited, Yokohama, Japan. So this is a publisher NHK Co Limited. So the books and recommended reading books and handbooks. So any doubts or any questions regarding your textbooks recommended reading, text handbooks, catalogs? Yes, anyone?
No, sir, no doubt.
Okay. Now and ESC, MST and end semester examination and assessment. So it's usual pattern that is 2020, 40 and 60. Now we see the first one is what is piping engineering. So piping engineer is anyone so who can install, repair and maintain pipes in chemical plants. So that kind of engineers we call piping engineers who installs, repairs and maintain pipes in chemical plants means like ONGC, that is oil and gas, that kind of and refinery industries. So here engineer can install, repair and maintain all kinds of pipes in chemical industries. So here piping engineering is a specialized discipline of mechanical engineering. It covers the design of piping and layout of equipments and process units in chemical, petrochemical or hydrocarbon facilities. So here we can think about vents and arteries pipes in chemical plants. So why we call the veins and arteries pipe in chemical plants? Piping network in a processing plant is like a network of veins and arteries in our bodies. It transports fluid from one place to another, from one equipment to another. It is a critical component of any process plant and requires good knowledge to deal with chemical plants or petrochemical plants or hydrocarbon facilities. Based on that, we can design, fabricate, and install the piping components. So that kind of work we can consider in piping engineering. Piping engineering, this engineering, engineer must understand the function of the types of pipes, different kinds of pipes. We must understand the function of a different kind of pipes involved and have a grasp of plant pipings. So here need to know which pipes are used for heating or cooling. So for this purpose, we required some basic knowledge and some sort of experience. So of course, experience will acquire after graduations and we are working in industries. And piping engineering typically starts with draftsman's blueprint, which illustrates where piping needs to be positioned. So here see the different kind of piping components in these two sketches. So that kind of blueprints means first draftsman will be designed. Therefore, we piping engineers typically starts with draftsman's blueprint. That kind of design we call the blueprints, which illustrate where piping needs to be positioned. Their responsibility range from laying down pipe to making repairs. So here we can repair the pipes. They often work odd and long hours and spend a fair amount of time traveling to multiple job sites. Many work as independent contractors and are for long periods in the event that an emergency repair is needed. This is the basic requirement of piping engineering. What kind of skill is required for piping engineers? Piping engineer must possess the strength and stamina. Why we need the strength and stamina? As they often lift and position heavy materials, as well as stand or bend over for extended periods. Therefore, we required strength and stamina, and they need to be skilled with their hands, and they are cautious on the job, as one mistakes could set a project back or create additional cost, that is unwanted cost in terms of monetary effect. Piping engineer should be attentive to details, must be attentive while dealing piping components in chemical plants or petrochemical plants or hydrocarbon facilities. Although these professionals must be able to work independently, they must also be capable of different instructions. In addition, they must exhibit the analytical skills necessary to read blueprints. We require analytical skills so that we can read the blueprints, means entire drawing of chemical plants or petrochemical plants or hydrocarbon facilities. In short, we call the piping layouts of chemical plants. So there are no set requirements to become a piping engineering. So only based on that prerequisite, that is a machine design and fluid mechanics. So therefore, there are no set requirements to become a piping engineers. Many learn their skills on the job or in apprenticeship. After 3 months or 6 months training, or we call the apprenticeships. So in that duration, so we can acquire the basic knowledge and experience. Some receives certifications after attending a piping course. Maybe long-term or short-term piping courses are there, so we can acquire the certificates. And other works in related fields, such as constructions, before making the transition to piping engineer. A background in math. So if I'm good in math, so it proves the beneficial to an aspiring piping engineers. So this is all about the basics, skills and backgrounds of piping engineers. So we call it is a half art and half science. So in arts, it includes visualizations and creativity. And in science, it includes certain established norms. These norms we call the code and standards. Piping is governed by international codes and standards. Which codes and standards to be referred for a given projects depends on client preference or local regulations. So we'll see some of the international codes and standards widely used world over. So that kind of codes are used in pipings. So any doubts in introductions, piping engineering and scope of piping
No,
engineer?
sir, no doubt.
Okay, we'll move on. Now next is codes and standards. What we are considered the different international codes and standards, which codes and standards to be referred to given projects depend on client preference and local regulations. So here we'll see the different kind of organizations for standards. So in piping codes, can define the piping codes. It's a requirement of design, fabrication, and use of materials, test and specification of pipes and piping systems. Code has limited jurisdictions defined by the codes. So with the help of codes, we can identify the requirement of designs, fabrications, use of materials, tests and inspections of pipes and piping systems. So that kind of work we can consider in codes. And what are the standards used in pipes? Some companies even publish their own internal piping standards based upon national and industry sector standard. Piping codes and standards from standard organization as NSI, that is, it stands for the American National Standard Institutes. So it is developed by United States. And here abbreviation is ANSI. It stands for the American National Standard Institutes. And another is ASME, that is American Society of Mechanical Engineers. And next is ISO standards. Here is ISO, that is International Organization for Standards. It is used worldwide. And DIN standards, that is DIN. So Dutch Institute for Normal Standards. It is developed by Germany. And other most common used in piping and piping system specifications. So here can go for the another code, that is SCC. It stands for the Standard Council of Canada. So it is developed by Canada. Another is AFNOR, that is Association Française. It is developed by France. And next is BSI. It stands for the British Standards Institutes. It's developed by United Kingdom. And next standard is CEN. So it is Committee of European Normalizations. It is developed by Europe. So it includes 10 to 15 countries and their designs, the CN uh, piping codes. And another is Japanese Industrial Standards Committee, that is JISE. It is developed by Japan. And next is Bureau of Indian Standards. It is developed by India. We call the MBIS. So here we can see the iOS. That is ISO. It is an international organization for standards. It is used worldwide. So that kind of federations of national standards bodies from some 100 countries develops the international organization for standards from each country. So that kind of code we call the ISO standards, and later we call the ISO 90s, ISO 2000s. Later they are modified. So that kind of codes we are used in piping engineering. So basically, in piping engineering, see the American standards are referred by the piping engineers. So these are the American Petroleum Institutes, that is called the API standards. Another is AISI. It stands for the American Iron and Steel Institutes. And third one is ANSI, that is American National Standard Institutes. And next code, that is ASTM, American Society for Testing and Materials. And next is AWS, that is American Building Society. Might be these two standards you are discussed in metallurgy science. That is ASTM. It stands for the American Society of Testing of Materials. When we are testing the materials in lab, so we are going to use the ASTM standards. As per ASTM standards, we can identify the particular properties of the material. For instance, we consider the MS or SS. That is, MS is nothing but mild steels, and SS is nothing but the stainless steel. So that kind of materials can find out properties based on the ASTM standards. Now, next standard is American Welding Society. So through this American Welding Society, so we can wear the piping components, and we can use the American Welding Society codes and particular standards. So based on that, we can wear the number of piping components. Now next is AWWA, American Water Works Association. So that kind of standards are used in piping industries where we are using uh, water works. In that case, we can go for the standards AWWA. Next code called MSS-SP. It stands for the Manufacturer Standardization Society of Walls and Fittings Standard Practices. So that kind of codes mostly used for the manufacturer standards as per the requirement of the local organization. So consider the MSSS-SP, that kind of code we can use for fitting the components, and we can use easily in different piping industries. So this is called as we call the piping uh, codes and standards. So in line with, we can see the API standards. So here, American different codes. For instance, so it can like so
Sir, we cannot hear you, sir.
yes, we can go for the API standards for piping components. So first one is the API, that is 5L. So we can go for that kind of codes for line pipes. And API 6D, we can use pipeline, walls, enclosure, connectors, and swells. And API 6F, so that kind of standards we can recommend it practice for fire tests for walls. So here we can use API 6F. And another standard, that is API 593. So here can use ductile iron plug valves and flange ends. So that kind of components use API 593. And next one is wall inspections and tests. For this purpose, we can use API 598 standards. And steel gate walls, we can use API 600s. Metallic cascades for refinery pipings, we can go for API 601. And next component, that is compact design carbon steel gate, will refer API 602. And corrosion resistant gate walls. So for this components, gate walls can use API 603. And another is ductile gate walls. For flange ends, we will refer API 604. So likewise, we can refer different codes for different piping components. For an instance, if we consider the butterfly walls, so here we can use the API 609. So that kind of codes we can use for the considering the piping components and standard for welding pipelines and facilities, we can refer API 1104. So that kind of codes are used in piping engineering. So here another is AISI standards. That is a American Iron Steel Institute standards. So with the help of these standards, so we can consider the chemical as well as physical properties of the materials. Means we can specify the chemical and physical properties when specific mode of manufacture the element is not concerned. So in this case, we can consider that is AISI 410, that is 13% chromium alloy steel. So here is a combinations of 13% of chromium alloy steels. In next code, that is AISI 304, 8 or 8, that is stainless steel. So might be these terms you are learn ferrite and austenite in metallurgy science. So that kind of materials are used AISI 304, and another is 18/8/3 Stantine stainless steel. So we can go for AISI 316. So that kind of standards we can use in different materials to identify their physical and chemical properties. Now, next standards, these are the ANSI standards. So here ANSI standards, so we can go for these standards considering the American National Standard Institutes use in the design of the piping system. So in 1978, they developed the ANSI B31. So then we can refer the ASME code for pressure piping engineering, that is B31. And subsequently, the code design was changed, and later, and then we call the ASME B31. So earlier we call the ASME code for pressure piping engineering, and later they slightly changed the code designations, and we call the overall it may be pressure piping engineering or process piping engineering. We call the ASME B31 code for pressure piping. It is present non-mandatory code in United States of America. They are adopted as a legal requirements. So here we can see the list of different power piping engineerings and their standards. That is, first one is the ASME B31.1. So we use that kind of code in power engineering. And next is a full gas piping. So ASME B31.2. And third one is process piping. That is ASME B31.3. And next fourth is pipeline transportation system for liquid hydrocarbon and other liquids. So for this purpose, we can use ASME B31.4. And next code for refrigeration piping is ASME B31.5. Likewise, gas transmission and distributor piping system. So we'll refer ASME B31.8. 8, and building service pipings would refer ASME B31.9, and slurry transportation piping systems, so that is ASME B31.11, and manual for determining the remaining strength of corroded pipings. It is a supplement of ASME B31.1. So, all that codes we are used in refinery and chemical plants design uh, based on the all standards and codes, and all power plants are designed as per ASME B31.1. So some factors we have to consider for a selection of design codes. Lest the agreement is specifically made between the contracting parties to use another issue, or the regulatory bodies having the jurisdiction imposes the use of another issue, then we can consider the different codes. For instance, we can go for the process piping, that is ASME B31.3. So some factors we have to consider. So these are some technical limitation of the code sections. They considering their particular applicability of other codes and standards. All applicable requirements of the selected codes shall be met. For some installations, more than one code section may be applied to different parts of the installations. For an instance, we can go for the more than one code section might be ASME B31.1, and another code is ASME B31.3. Means here we can use power piping as well as process piping. So sometimes for some installations of piping components, we can refer more than one code sections may apply to different parts of the installations in piping engineering components. So here piping engineer, or we call the user, is responsible for imposing the requirements. So that kind of supplementary to those of the code if necessary to assure safe piping for the proposed installations, where no section of the code, see, you see the different kind of codes. For if you consider LSI or ASME, some dimensional standard codes, so that we can consider when no sections of the code specifically cover the proposed installations. For instance, if you consider the ASME B16.9 for steel butt welding fittings, and another is ASME B16.4, that is a cast iron threaded fitting. So in this case, we need to specifically cover the proposed installations. The piping engineer has the discretion to select any sections based on the requirement in chemical plants or petrochemical plants or hydrocarbon facilities. So the code sets the fourth engineering requirements deemed necessary for the safe design and construction of pressure piping. While the safety is the basic considerations when we are considered all different kinds of codes, then safety, the basic considerations. This factor alone will not necessarily govern the final specifications of any piping specifications. If you consider the ASME B16.47 large diameter steel flange NPS, that is nominal pipe size 26 to 60, or ASME B16.34, that is steel walls, flange and butt welding ends. So these standards a requirement, the different sections once we chosen may be necessary to provide the safe piping systems for the intended applications. The code sets fourth engineering requirement deemed necessary for the safe design and construction of piping engineering or process engineering. While safety is the basic considerations, this factor alone will not necessarily govern the final specification of any piping specifications. When we, for instance, if you consider ASME 16.28 short radius elbow and returns. That kind of piping components are used in chemical plants, petrochemical plants, or hydrocarbon facilities. So the code prohibits the design and practice known to be unsafe and contain warning where consideration but not provisions is warranted. A designer must be keen that the code is not a design handbook. It does not do away with the need of the engineer for the engineers or the competent engineering judgment. So that kind of code are we are considered in different standards when we are dealing with codes and standards. Now next code is ASTM standards. It stands for really we consider the American Solar Testing of Materials. Here we can see the four parts of the sections. When we call the ASME standard consists of 16 sections. When we see the handbook Mohinder Nayak, then there is 16 sections of American Society of Testing of Material Standards. But here we are concerned with four parts. That is and classification of material construction and test methods. What they define in ASME standards. So classification of material and construction and test methods. So most of the ASTM standards are adopted by ASME. So American Society of Mechanical Engineers and are specified in ASME section 2 in design in material handbooks. They are specified ASME section 2. In section 2 has four parts. First one is that is part A. So it contains ferrous materials specifications. Now next part B, non-ferrous metal specifications, material construction and test methods. Part C, specification for welding materials, and part D, properties of the materials. So in part 2, the material are listed in the index based on the available forms such as plates, castings, tubes, etc. and so on some numerical indexes, while we can consider their composition of different elements. The selection of ASTM specification depends upon the type of manufacturers, form of materials, its mechanical strength, and the corrosion properties. So that kind of requirement is required for the selection of ASTM specifications when we are dealing with part A, part B, part C, part D means ASTM specification depends on the type of manufacturers, form of materials, it is a ferrous materials, non-ferrous materials, and their particular specifications and its mechanical strength and the corrosion properties. The specification number is given in handbook on alphabetical prefix. So here, if you consider the part A stands for the ferrous materials. So if you see the ASTM standards, part A means only ferrous materials, and part B means for non-ferrous materials, and part C stands for the only specification for welding materials. Here welding materials are available in part C. And part D, only properties of materials are available in ASTM standards. So these are the parts. The ASTM standards, if you can pick the part B, means non-ferrous metals and their specific properties. Based on that, we can easily pick the numbers, and also the ASTM specify the standard practice for numbering metal and alloys. So they can consider the some numbers. Suppose here ferrous F001 or F0312. That kind of numbering are used for metal and alloys. That is called as unified numbering system. That kind of system we call unified numbering system. So can use that kind of standards. Now here another standards, if you consider the AWS standards. AWS standards is nothing but the American Welding Society. It provides information on welding fundamentals. What kind of welding fundamentals we are learn in workshops, different kind of welding process, and we weld on the job. So here, with the help of this AWS, that is American Welding Society, it provides information on welding fundamentals, like a weld design. So what kind of weld design is required? Welders training qualification. This is very important. So ordinary person cannot weld. It requires some qualifications. So based on that, he can weld the piping components in chemical plants or in petrochemical plants or in hydrocarbon facilities. So that kind of, and then testing and inspection of welds. This standard provides the testing and inspection. This AWS standards. It provides the testing and inspection of welds and guidance on the application and use of welds. So here we can use the individual electrode. So for this, we need some individual electrode manufacturers have given their own brand names. Some electrode manufacturers are use their own brands, and they use in chemical industries and different plants for the various electrodes and are sold under these names. So they can use that kind of electrodes, and they sold in markets using their brand names or different names. You know, that kind of manufacturers we call the manufacturer standard, that is MSSP. So that we are considered the manufacturer standards. So these are the manufacturer standards. When we consider manufacturer standardization society as per their standards, so they can use their names, and can use in different chemical plants or petrochemical plants. Now, next standard is AWWA standards. So it stands for the American Water Works Association standards. It refers to the piping elements required for low pressure water services. So low water pressure services means we can use that kind of standards in domestic pipe layout system in different cities or towns. In villages, we can go for the AWW standards. So wherever we require low pressure water service. So for this, we can go for the AWWA. These are the less stringent than other standards. So here we can go for the walls, flanges, elbows, couplings, unions. So that kind of piping components are used. It requires for large diameters water pipelines. You see the water pipelines having the large diameters for water pipelines covered under these standards, and rarely it is referred by CPI piping engineers. So that kind of earlier refer the CPI piping engineers. Later, they are subsequently changed the designations and they are used the AWWA standards, that is American Water Works Association. So that kind of standards we are used in different um, um, plants. And another standards that is Mssp standards. In addition to above standards and material codes, they there are standard practices followed by manufacturers. They are the manufacturer standards. Therefore, we call the MSS-SP standards. These are published as advisory standards and widely followed. A large number of MSS practice means manufacturer standardization society have been approved by the ANSI, American National Standard Organization, and ANSI standard published by others. In order to maintain a single source of authority informations, the MSS withdraws those standard practice in each cases. The most common MSS-SP standards referred for pipings are, see here, MSS-SP 6 standard finishes for contact surface of flange, standard making system for walls fittings flange, MSS-SP 25. So likewise, we can use different manufacturer standardization societies standards. So for butterfly walls, cast iron gate walls, cast iron check walls, ball wall, cast iron plug walls, branch gate, globe and check walls, and pipe hanger supports, material design and manufacture. So we can use different standards, that is MSS-SP-56. So can use different kind of standards in chemical plants. So here you can see the different kind of standards we are using in piping engineering. So another standard is British standards. So this we call the BS. It stands for the BS. BS10. We can go for the BS10 for the flanges. In many instances, it is possible to find British standards, which may be substituted for American standards. Now, the community of European normalization is issuing standards, replacing different standards in force in the European countries. So, accordingly, a lot of BS and DIN, that is Dutch, standards are getting replaced by CN standards. And there are certain British standards referred by Indian manufacturers. So in our country, we are use some BS standards for the construction of piping elements such as walls, flanges, couplings, elbows, unions, that kind of piping components we can construct with the help of BS standards in India. The most commonly referred British standards in the piping industry are BS10, BS806, BS916, BS90970, BS1212 specification for float operated walls. So these are the different standards are used in chemical plants. Now next standard, that is Indian standards. So we call the Bureau of Indian Standards, BIS, have so far not developed an Indian standards for the designer piping systems. So hence ANSI standards, ASME B31.3, this one, BS, ASME, ASME B 31.1, power ASME B31.1 widely used for the design in Indian standards. These standards accept material covered in other standards. Unlike American standards, Indian standards covers dimension and material specification under the same standards. So here you can see the BS2598 glass pipeline and fittings. So for periodic review of the standards by the committees head, and these are revised to incorporate the modified features based on the results of the research from the industries, and some technological lacks are unavoidable, so that we can consider all the standards they are used in different countries. DIN standards are more popular, and equivalent British and Indian standards are also available for certain piping elements. So this is all about code and standards. So do you have any questions? So you can ask your question doubts. Yes, now.
No, sir, no doubts.
Hello.
No, sir, we have no doubts.
No, sir, no
Okay,
doubts.
fine. Very good, very good. Then we'll close this meet now, and we'll meet next lecture. Okay.
So thank you, sir.
Thank
Okay,
you, sir.
welcome.
Thank you, sir.
Okay, welcome.